Hey guys, welcome to day 5 of solving Leetcode daily challenges. Today's problem is hottest building you can reach. So what is the statement states? That is, you are given an integer array heights representing the heights of the buildings. Some bricks and some ladders are given. We need to start journey from the building 0 and move to the next building by using bricks or ladders. Let's say we are moving from building I to building I plus 1. Then if the current building's height is greater than or equals to next building, then we don't need to use ladder or bricks. If we say the current building's height is less than the next building, then we need to use either ladder or the bricks. That is, how many number of bricks should we use is height of the current building or height of the next building minus height of the current building. Okay, so let's take a simple example given here. They are given the heights 4, 2, 7, 6, 9, 14, 12 and bricks, 5 number of bricks and 1 ladder is given. Let's take this as an example. So here it is 4, right? 4 to 2. It takes only, it doesn't take any brick or ladder to jump from 4 to 2. And then from 2 to 7, we need 5 bricks. So let's visually see this example. Okay, so let's take an example. So 4, 2, 7, 6, 9, 14 and 12. So this is the given array of heights, that is H. And next we are given with number of bricks equals to 5 and number of ladders equals to 1. Now let's draw the building heights, like it is 4 and it comes 2 and then let's say 7, 6 or 9, 14 and 12 are the given heights. Let's first see if the current height will be will take it from here. So the current height is less than the previous. So we can just jump it here without any use of bricks or ladders. Let's say we are moving from 2 to 7. So 7 minus 2, it becomes 5. Or we can say the current index is greater than the previous one. So we need either a ladder or 5 bricks. So we'll let's say we are using bricks first. Then we'll use 5 bricks here to make it equal height and jump it over here. And we see that 6 is less than 7, so we'll just jump it here. And we'll see that 9 is greater than 6, and we have only, like, if we use all the bricks here, then the number of bricks will become 0 and we need to use the ladder. So we'll take a ladder to here and we'll reach to the 9th building. Next, let's see if the next building is greater than or less than. So we see that 14 is greater than 9 and we have 0 ladders and 0 bricks left. As we used a ladder here, the number of ladders becomes 0 and we have no ladders or no bricks. So in this condition, just return the index of 9. That will be 0, 1, 2, 3 and 4. 4 is the index and we'll return this index as the answer. Let's see another example. Take what if we use this, like 4, 12, 2, 7, 3, 18, 20, 3, 9. It is the heights array, and let's say we have number of bricks equals to 10 and ladders equals to 2. Let's check first, like we'll draw buildings. Okay, so now let's check if this 4 is less than or equals to 12. So 12 is greater than 4. So we need 8 bricks or 1 ladder? Let's say we choose the bricks first and we have used 8 bricks. Then the bricks becomes 2 and we'll reach the 12 building, 12 height building. And from here, we check that 2 is less than 12. So we'll just jump here and we can see that 7 is greater than 2. Means we need 5 bricks. But we have only 2 bricks. So we'll use a ladder here. So we'll use 1 ladder here and let's move to the next and we'll just decrease the ladder to 1. We can see that 18 is greater than 3. Actually, if we use bricks, then 18 minus 3, that is we need 15 more bricks. But we have only 2 bricks. So we use 1 ladder here. So let's say we have used a ladder. And then this one will become 0, that is we have left with 0 ladders. And in the next case we'll see that 20 is again greater than 18, and let's see if number of bricks equals to 2, and we see that we have exactly 2 bricks. So okay, we'll use this bricks to dump here. And next we'll see that 20 is greater than 3. That means we can easily jump from this building to this building without any ladders or bricks. So next we'll see that we have no bricks and no ladders, that is bricks equals to 0 and ladders equals to 0. And we need 6 bricks or a ladder here. So we can't use. So we'll just return the index of 3. That will be 0, 1, 2, 3, 4, 5, 6, 7. That is we can reach up to 7 buildings by using 10 bricks and 2 ladders. Let's move to the approach what we have used. So we have used the bricks at let's say first we have used 8 bricks and then 12 bricks, 2 bricks. We can say that we have used bricks only for the least or smaller number of jumps. What we have seen here is here we need to use 5 jumps or 5 bricks. We can use bricks here also, but we already used 8 bricks here. But what if we use ladders first? Let's take a simple example. 12, 2, 7. So this is the heights array, and let's say bricks equals to 10. And number of ladders equals to 2. What if we use first ladders? We can say that 12 minus 4 equals to 8 bricks. What if we use ladders instead? We use a ladder here and number of ladders is decremented by 1. And then we can see that 12 is greater than 2. That means we can directly jump to 2. And now we see that 7 is greater than 2. So we need 5 bricks in this case. So we'll use 5 bricks and number of bricks is reduced to 5 as we used 5 bricks. Then we can easily jump to third height building, and we can see that 18 is greater than 3 and we need 15 bricks. So we need to use 15 bricks, but we are left with only 5 bricks. So we'll use ladder in this case. So we use ladder to move from 3 to 18, and we can see that now again 20 is greater than 18. So we need 2 bricks. As we can see, this is less than 5 and we are left with 0 ladders. So we just use this bricks and jump to building of 20 height, and the bricks becomes 3. So we are left with 3 bricks, and we see that we can easily jump from 20 to 3, and now we can see 19 is greater than 3. So we need 16 more bricks. But we are left with only 3 bricks. So we can't use these bricks and we just can't reach this height. So we return the index of 3 as 7. So answer will be equals to 7. So we see that if we use ladders or bricks first, it doesn't matter and we can reach the index, or we can reach the same building. Okay, so now let's think of a solution. How can we do it in an optimal way? Let's say we are searching for the building or target that we can reach in every possible way, like using bricks or using the ladder. So let's check for we can reach a target or not. It's like searching a particular element in the array, so we can use binary search in this case. So let's take an example of 14, 3, 19 and 3. This is the height array, and let's say number of bricks equals to 17 and number of ladders equals to 0. Let's take no ladders first, and we'll write it as 0, 1, 2 and 3. Let's say h, or left is here and right is here. We are taking a binary search, so L will be equals to 0 and R will be equals to 3, and mid will be equals to L plus R by 2, that is 1. Let's say L plus R by 2. Now we'll check if the target is reached or not. Let's say we reach the target, and we'll search if we can reach target plus 1 also. Say we'll see that this is the mid, right? So it will be mid, and we'll check if we can reach 3 and also 19. What if we reach target and we not reach the target plus 1? That is, we reach the target, that will be like my mid, and we'll just return the mid. What if we reach the target and we reach target plus 1 also? Then we'll just increment the left value to mid plus 1. And what if we didn't reach both target or the target plus 1? Then we'll just decrement the right value to mid minus 1. Let's see how this works. Okay, so first we took the array as 14, 3, 19 and 3. Let's say L is here and R is here, and my mid will be M. So first we'll check if we can reach this or not. How to check if we can reach the particular target or not? We'll see, we'll take a jumps array as how many till the target value, that is till here. We see how many jumps are there. We see that 14 is greater than 3. So we can directly jump from 14 to 3 without any use of ladder or bricks, and we can see that jumps array is empty, that is equals to number of ladders in this case, only in this case. So we can see that no bricks are needed and no ladders are needed, so we'll just return true, that is we can reach the particular target. Let's see if we can reach mid plus 1 or not. Then my jumps array will have, that is 19 is greater than 3, so we have to jump for 16, right? So the jumps array will have 16 here, and we have number of bricks equals to 17 and ladders equals to 0, so we can use this 17. We see that length of the jumps array is not equals to ladders, so we'll see that required array or required number of bricks equals to 16 and the number of bricks equals to 17. In this case it is less than 17. Yeah, we can use the bricks and we can reach the target. So we reach target plus 1 also. So we reach both the cases. So we increment the L value to mid plus 1. Now the new mid will be mid plus 1, that is equals to 2. And L will be R will be equals to 3, and mid will be equals to 2 plus 3 by 2, that is equals to 2. So the mid and L are at same index, and we see that number of jumps is equals to, we now consider till this, so number of jumps is equals to 16, and we see that we can reach 16 in the previous case, so we say it's true. And next we'll move to the next index, that is can we reach mid plus 1, that is can we reach till 3? We see that there are no more jumps, we can directly jump to 3. So we in this case also we see that the jumps array equals to 16 and we can reach this. So we see that we can reach both the target and target plus 1. So we increment the L value to mid plus 1, that is equals to 3. We see that L equals to R. So we'll just come out of the loop and return left. Let's move to the code part. Let's say n equals to length of heights and l comma r equals to 0 comma n minus 1. As we are using binary search, let's say while l is less than or equals to r, mid equals to l plus r by 2. Let's think of a condition like what if there are only one building present. Then we can say that if mid equals to n minus 1, we'll just return this mid. Now let's see, we can reach the target, and can we reach target plus 1 also? Okay, how can we see that? We'll use a simple approach, like we'll use def can reach the target. We'll reach, say, h number of bricks used, number of ladders used, and the particular target. We'll initialize the jumps array first, like jumps list, and then we'll see till the target how many jumps can be done. Say for I in range of the particular target, we'll see that difference equals to height of I plus 1 minus height of I. We'll check that if the difference is greater than 0. If it's greater than 0, then only we can move to the next building by using bricks or particular ladder, right? So we'll just append this difference in jumps. So next we'll see the condition, like can we say what if the number of jumps is equals to ladders? Can we use only ladders to make every jump? So we'll check if the length of jumps is equals to, or we can say that less than or equals to ladders used. We'll just return true, that is we can reach the particular target. What if it's not true? Can we say that a number of jumps is more than the ladders used? So first, what condition we used? Like we used the smaller jumps first. So we'll sort the particular jumps and we'll see how many number of bricks we are using to jump. So can we say like we have used L number of ladders already, and we can say we are going to use the ladders at the end. So we can say that a required number of, or we can say number of jumps required or equals to length of jumps minus ladders, or we can say the jumps made using bricks can be equals to length of jumps minus ladders. And we'll check number of bricks needed first. So bricks needed can be equals to the sum of jumps only till the particular required jumps. So we can say your required jumps. So it's till j we'll check, and we see that if this bricks needed is less than or equals to bricks we have, if it's true, we'll just return true, that we can reach the particular building or target. If it doesn't meet, so we'll just return false, for we are not able to reach the particular target. So we'll see that self dot can reach of heights bricks comma ladders comma particular target will be our mid. So will be mid, and in this case we are just checking till target plus 1, so mid plus 1. In now we'll check what if we can reach the target and cannot reach the target plus 1. So in this particular case we'll just return the mid. And what if we can reach both the cases? So we can reach mid and mid plus 1. So we'll just increment our left equals to mid plus 1. What if we can't reach both the solutions or both the targets? So we'll just increment, or we can say update the right to mid minus 1. And what if we have reached all the buildings? Then we'll just return left. We'll check if the code is running fine or not. Yeah, it's accepted. Let's just submit the code. Yes, the code runs fine for every test case. Let's see the time complexity and space the complexities. So here we see that we are sorting the jumps array. Let's say in the worst case, the target can be equals to n minus 1 or length of the array. So in this case, we need order of nlog n, and for the binary search, we are using log of n, right? So and say for this, we are using order of log n. So the total time complexity of the program will be equals to order of n log square n, right? I mean n log n whole square. So in order to minimize this, how can we minimize it? Can we think of a greedy solution, like instead of using a binary search, like can we reach the target or not? Can we say we can use a priority queue or min heap to just minimize this time complexity? Let's see if we can do this. Let's first discuss the code part and then I'll just explain the dry run. Okay, so we are taking n equals to length of heights and jumps equals to list. And let's say for I in range of n, difference will be heights of I plus 1 minus heights of the parent building. And if the difference is greater than 0, then we are appending the difference into the jumps. But we are using a heap queue here. So we'll just do heap q dot heap push of jumps comma the particular difference. So every time we are appending the difference into the jump, it itself heapifies it, like the smallest difference will be at the top and the maximum difference will be at the bottom. So we need not sort the jumps array. It reduces the time complexity. So now we'll just see if the length of jumps is greater than the ladders. In this case, we need to use bricks, right? So we just see that number of bricks required equals to heap q dot heap of jumps. That means we are taking the least or smallest difference first, and we'll check if the bricks required is greater than the bricks we have. So if it's true, I mean if the required bricks are greater than the number of bricks, we'll just return the particular index. And if it's not true, that means we are using a lesser number of bricks. So we'll just reduce the bricks to bricks minus equals to required bricks. And what if we have used all the bricks on ladders and we have reached every possible building? So we'll just return n minus 1. That is, we have reached the last building also. Let's run this code. Okay, so Yeah, the code runs fine. Let's just submit it. Okay, so the code runs fine for every possible case. So let's move to the dry run. Like h equals to 14, 3, 19 and 3. Okay, so we are taking a heap here as j, and now we'll move from I to n minus 1. We see that the difference is minus 11 in this case, which is less than 0. So we won't append difference into the jumps. Next we'll check that 19 is greater than 3 and the difference is equals to 16. So in this case we see that it is greater than 0. So we'll just append it into the min heap and we take it as bricks equals to 17 and number of ladders equals to 0. We see that length is greater than the number of ladders we have. So in this case we need to use bricks. So we'll just pop it out. Let's say we don't have this in this min heap. So bricks needed will be equals to 16 and we see that this 16 is less than the 17. That means we can use further more bricks. So now the number of bricks will be equals to 1 and we have used the 16 bricks. We'll move to the next index. So we see that 19 is greater than 3. That means 3 is less than 19. So the difference will be equals to less than 0. So it will be in minus 16, right? So we just don't append anything. And in this case, we have reached all the possible buildings. So we return this index that is equals to 3 as answer. Okay, so let's think about the time complexities here. So we are using the min heap till the capacity of ladders. So at worst case we are just sorting the number of ladders here. So we can say the time complexity will be n log of number of ladders used and the space complexity will be the number of ladders. That can be like we are seeing condition that what if the length of jumps is greater than the ladders or not. So the space complexity will be order of ladders. We'll check here that in this popping and here the time complexity will be equal to order of n log of ladders used and the space complexity is order of ladders. So that is it for today guys. Meet you tomorrow in next daily challenge. Thank you for watching.